Okay, so in the Minds On, I asked you to compare the two patterns 2n plus 5 and the second pattern 5n plus 2. And I asked you, how would these patterns be the same and how will these patterns be different? So some people might have started different things to try to figure this out. What I'm going to do is I'm going to create two tables. So I'm going to create a table for 2n plus 5, and I'm going to create a table of 5n plus 2. And it's okay if you drew the patterns out in order to compare them, or compare them in any way that you saw fit best. Okay, so if I am creating this table, so position 0 for this first one, for example, to figure out what that position 0 is, I'm going to take 2 and times it by 0 and add 5. So 2 times 0 is 0, and if I add 5, that gives me 5 for my first position. And then if I wanted to find position 1, there's different ways that I could go about it. I'm going to go 2 times 1 plus 5. 2 times 1 is 2, and then I add 5, and that gives me 7. Okay, so I'm going to write 7 here. Or what I might see here in my table is that since my rate of change is 2, that I'm adding 2 to this pattern each time. So I'm going to take to figure out what that next position is. So if I'm looking at position 2, 7 plus 2 gives me 9. If I'm looking at my third position, I'm going to take 9 and then add that 2, and I'm going to have position 11. Okay, so then what does that second pattern look like? So again, position 0. So if I do 5 times 0 and I add 2, that's going to give me 2. If I'm in position 1, so in this case, my rate of change is 5, so I'm going to add 5. That's going to give me 7 in my first position. If I keep going, so position 2, add 5, that's going to give me 12. If I'm in my third position and I add another 5, that's going to give me 17. So it said, how are these two patterns the same and how are these two patterns different? Okay, so some things that I've heard in the past. So if I'm thinking about how are they the same, I might say that these are both linear patterns. And I know that they're both linear patterns because they have that constant growth, meaning that they go up by the same amount each time. I know that position 1 is the same because for both of these patterns in position 1, I have 7 tiles. So that's something that's the same. And I might even say that they're both growing patterns because they're getting bigger as we move on in position numbers. What things might be different? That they start in different places. So when I look at here, I've got my first pattern starts at 5 and my second pattern starts at 2, so they start in different places. And that they grow at different speeds. Different speeds or different rates. So when I look at these patterns, one goes 2, 7, and then all of a sudden it gets bigger. So something that I might say is that this 5 is causing my pattern 2 to grow faster than my rate of change of 2n. So let's make a little bit of a rule here. The larger the rate of change, the faster the pattern grows. And the smaller the rate of change, the slower the pattern grows. So I want you to look at these examples here. I want you to decide out of these, and if you're not sure what this means, I'll write these patterns out. So this is 4n plus 9, this is 7n plus 8, and this one's 5n. Which of these patterns is going to grow most quickly, and why do you think that? Which one do you think is going to grow slowest, and why do you think that? Pause the video, write down your thoughts, and then we'll take it up in a second. Okay, so if I want to figure out which one is fastest, B is going to be fastest because my rate of change, so my A value is equal to 7, and that's the largest rate of change. And I'm just going to write ROC for rate of change. So this 7 is going to make this pattern grow fastest. On the other hand, A is going to be slowest because 4 is the smallest of my rates of change. So A is equal to 4, and it's going to be the smallest rate of change. So if I look at the speed at which that pattern grows, it's going to be the least. Okay, we're going to work through 4 different examples, and I want you to think about how are the relationships or how are the patterns either the same or different. You might add to your table of values. I would encourage you to come up with some rules to help you compare them. Okay, so I'm going to give you a minute, pause the video, press play when you are ready. Okay, so hopefully you've tried this. I'm going to jump to my pattern first, just because I can see right away the way that this is growing. So something that I will think about, okay, I've got this piece of my pattern staying the same each time, so that I know that my constant or my B value is going to be 3 or 3 tiles. And I can see that my pattern each time is growing by 2. So my equation in this case, and we might be changing it to y equals ax plus b form, or you might be writing it with t's still. So some people might be writing their equation t is equal to 2n plus 3, or you could be writing it as y equals 2x plus 3, just meaning that my input is my x, my output is my y. Okay, so there is my equation for that first one. And then for my second equation, so if I look at here, to get from 1 to negative 1, I'm going to subtract 2. To get from negative 1 to negative 3, I'm going to subtract 2 as well. And I'm going to double check here. This is going up by 1 each time. So my rate of change is going to be negative 2 over 1, which is just going to be negative 2, just making sure that I'm not skipping any positions. If I want to find my constant, I can do that in 2 different ways. I can either take my multiplier, so my negative 2, and times it by 1 to get negative 2. What do I need to add to negative 2 to get positive 1? I have to add 3. Or I could work backwards and find my 0 position. We do that in a different color. So if I work backwards and I add 2 to 1, I find that my constant is going to be 3. So my rule for this equation, and I'm going to use my y equals equation, y equals my rate of change, negative 2x, and my constant is 3. If I want to figure out what's missing in these boxes here, I can take that negative 3 and put it into the formula. So negative 2 times negative 3 plus 3. That gives me positive 6 plus 3. So this box should be 9. And this one here, negative 2 times 10 plus 3. That's going to give me negative 20 plus 3, which gives me negative 17 in this box. Okay, so now if I compare my 2 equations, y equals negative 2x plus 3 and y equals 2x plus 3. So I'm going to compare those 2 things. So I'm going to look at what is the same and what is different. So in this case, they both have the same constant. So that's that plus 3 value. They are going in different directions. So meaning one is increasing and one is decreasing. And I know that because one has a positive rate of change, meaning increasing. And this one has a negative rate of change, which means decreasing. I can also say that they're growing or changing at the same speed. And the reason why that they're changing at the same speed is that even though they're going in different directions, one's going up by 2 and one's going down by 2. So they're both changing by 2. Okay, so there we go. Let's try another one of those. What's the same about these relationships and what's different about these relationships? Pause the video and try, and then we'll take it up in a second. Okay, this example is a little bit trickier because you'll start to notice that my patterns are changing by a different amount. So for example, in my table, I can see that my growth is changing by 2 each time, or my position's changing by 2 each time. And in my pattern, it's also changing by 2 there, but changing by 1 here. So sometimes some people might say that this isn't linear because they're seeing unconstant growth, but notice that I'm skipping patterns or position numbers. Okay, so if I look here, my pattern from position 2 to position 4, I've gained 8 tiles, so I'm going to write plus 8. And then from position 4 to position 5, I've grown 4 tiles. So if I want to think about what my A value would be, I can take 8 and divide it by 2, which gives me 4. Or for the second one, I could take 4 over 1, and that also gives me 4. So my rate of change in this case is y equals 4x. But now I need to figure out what my constant is. So if I look at this case here, or I could work backwards, so I could work backwards to the 0 term. So if I take away 2, at that same time, I'm going to take away 8. So if I take away 8, I'm going to be left with that single triangle. So my constant in this case is plus 1. Okay, so now let's look at the first pattern that's in my table. So if I go from 5 to 13, that's going to be plus 8. If I go from 13 to 21, that's going to be also plus 8. To find my rate of change, I'm going to take my change in y and divide it by my change in x. So I'm going to take 8 over 2, and that gives me a rate of change of 4. So I'm going to write y equals 4x. Well, now I need to figure out what my 0 term is. So if I work backwards 1, I'm going to work backwards 4, and 5 minus 4 is 1. So I've got 4x plus 1. Now we'll notice that both of these patterns are the exact same. They have the exact same rates of change. They have the exact same constant. The only thing that's different is that they've given us different position numbers in our tables and in our patterns, and that made it a little bit harder to see. All right, let's try the next one. What is the same about these relationships and what is different in these relationships? Pause the video and see if you can find out. Okay, so again, I tend to go to patterns first. It's just my area that I feel most comfortable in. So I'm going to, from position 2 to position 3, so I am changing my positions by 1. In this case, I'm taking 1 box away. I'm taking 1 box away. So my rate of change is take away 1, so negative 1x. Now I need to work backwards to find my 0 term. So now I'm going to subtract 2. So if I do subtract 2, I'm going to subtract 2 from above. So, or sorry, not subtract 2, I'm doing the opposite, so I'm going to add 2. So I'm going to have 5 tiles. So I'm going to have negative 1x plus 5. Okay, and now moving on to my table. So if I go from negative 1 to negative 7, I'm subtracting 6. If I go from negative 7 to negative 13, I'm subtracting 6 again. And now if I look at from 2 to 4, I'm adding 2, and I'm adding 2. So I need to find my rate of change by taking what are my y values changing by what are my x values changing. So negative 6 divided by 2, and I get negative 3. So my rate of change in this case, y equals negative 6x. And now I'm going to test and see if I can figure out what my constant is. So negative 6 times 2 gives me negative 12. Well, I need some values a little bit bigger than negative 12. Oh, sorry, I wrote the wrong multiplier. Rate of change. Give me 1 second. Negative 3x. So I've got 2 times negative 3, which gives me negative 6. And I have to add 5 to get to negative 1. So my constant in this case is plus 5. So now I'm going to take a second and I'm going to compare what is the same about these two pattern rules and what is different. Okay, so if I'm looking at what's the same, again, they're both linear rules. They both have that constant growth. They are both decreasing relationships because they're both negative. So if I look here, they're both decreasing because I have a negative on both patterns, meaning they're both going down. And they have the same constant. So what I'm looking at there is that they both have this plus 5. What is different in these relationships is that they are going down at different rates. And when I look at these, pattern 1 is changing faster. And I know that because it has a larger rate of change. So when I'm talking about my rate of change in terms of which one is larger, I'm like 3 is bigger than 1. So my pattern 1 is changing by 3. Okay. In which of the tables below is it easier to find the rule and why? So I want you to take a second. I want you to see if you can find the rules for these patterns and then come back. Okay, so when I look at pattern 1, this goes up by 7. Then we're going to go up by 7 again. And then we're going to go up by 7 again. So I have y equals 7x. Oh, and just do a double take. Okay, also goes up by 1, so we don't have to divide. Now, what's missing is my constant, or my 0 term. So we're going to work backwards in our table to get to that 0 term. So subtract 7, and that gives me a constant of 3. And then we're going to try the second one. What I like about this table is that right away when I look at it, my constant is given. So I can start by writing y is equal to, I don't know my rate of change yet, so I'm just going to leave a blank there, minus 3. Now I have to find my rate of change. So how do I get from negative 3 to 18? I'm going to add 21. From 32 to get to 18, I'm going to add 14. When I first look at this, it kind of looks like it might not be linear, but that's a trick that's often happening when we're looking at patterns. So from 0 to get to 3, I have to add 3. To get from 3 to get to 5, I'm going to add 2. So if I try to find my rate of change, I'm going to take my change in my y, so how much my t values are going up by, 21 divided by 3, which gives me 7. And then I check to make sure that the other one is growing by the same amount. So I'm going to go 14 divided by 2, and that gives me 7 as well. So in this case, I get 7x minus 3 because my rate of change was 7. Often, when I'm given patterns that grow by 1 each time, those rates of change are a little bit easier to find than ones that skip particular values. But both of them are completely doable, and you've got this.